Fetchers of America, welcome back to Rich and David TV. Here we are teaching you math online. I hope you're in your pajamas or in your workout clothes. I hope you're eating Captain Crunch and killing it coronavirus 2019 style. Check it out, okay? We're going to teach you division of polynomials, section 4.8. Can you see over here, Brother David?
Yes, I can.
Okay, so 4.8. We're talking about division of polys, okay? First thing I want you to understand is we just got done teaching you last week before you left on vacation, whatever you want to call this, multiplication of polynomials. We talked about how we have a mono times a mono, and then there was a mono times any poly, and then there was, a binomial times a binomial, and any poly times any poly. Those are the four types of multiplication of polynomials, multiplication of polys. Division of polynomials, okay? There are two kinds of division of polynomials that you run into in algebra. The first is any poly, including a monomial, divided by a monomial. And then there is the any poly divided by a binomial. Now I need you to watch this because I'm going to put a big old through that right there, and we aren't going to teach you that. That's the second half of section 4.8. So we're only going to do in your assignment tonight 1 through 23 odd, unless you're planning on doing some extra credit. You could do up to number 24. But there's more than 24 problems in section 4.8, and it's about division of binomials. It's a challenging concept. We don't teach it in beginning algebra, and so I don't recommend that you go past 24. You will not be tested on it. We don't teach that concept, all right? So I'm going to grab the eraser real quick. Can erase this. And so if you look at this, we're going to learn about how to take any polynomial divided by a monomial. Now, let's leave that up there for a second. I want you to look at these two problems up here, and I want you to tell me real quick, are these problems the same? Pause. All right, so you thought about it for just a second. I hope you looked over these two problems. It's always good to pause and to check that out. You can always pause and restart these videos. They are exactly the same problem. You have a trinomial, three terms, 4x to the fourth y. There's a 4x to the fourth y, minus 8x to the sixth y squared, minus 8x to the sixth y squared, plus 12x to the eighth y to the sixth, plus 8x to the eighth y to the sixth. Those are the same trinomial divided by 4x to the fourth y. This is a big division bar, therefore divided by 4x to the fourth y. These two problems are the same. And you can see problems in the homework and on the test written in either of these formats and know this is division of polynomials. Notice here we have a polynomial or a trinomial divided by a monomial. And we talked about this before. Everything's a polynomial, whether you're a mono, a bi, a tri, whatever, okay? But there's a trinomial divided by a monomial, and so this fits the description, any poly divided by a mono. Okay, let's go ahead and pause. All right, so I erased the one side since they're both the same problem, and we're going to leave this one up here to do. So here's your steps. This is your rubric or your recipe to be able to divide any polynomial by any monomial. So our first step, very simple, we're going to place the mono under each term in the poly, okay? So we're going to take this 4x to the fourth y, and we're going to place it under each term in the polynomial. That makes sense. So we have a minus here, that's going to drop down. We have 8x to the sixth y to the second. That's the second term in the polynomial, and we're going to place the mono, okay, underneath that. Okay, so we come back to this. Place the mono, okay, that's what's in the bottom here, the monomial, under each term in the polynomial. So now we're going to take plus 12x to the 8th y to the 6th and put it over 4x to the 4th y. We've talked about this concept before, that if we have, a plus b plus c all over 3, that's the exact same thing as a over 3 plus b over 3 plus c over 3, okay? Same kind of a concept here. This entire polynomial over the single denominator, this monomial, we can take each thing and these two things are the same, just like this concept here. I'm going to quickly erase that. The next thing we do is that we simplify, okay? We simplify. And pretty cool here. Numbers go with numbers. Why is this pretty cool? Because this is the exact same concept that we taught and talked about with multiplication of polynomials. Okay? X's go with X's. Y's go with Y's, and etc. Now, one of the things that you want to do with these variables is you want to remember what we call the quotient rule in our laws of exponents, the quotient rule. If you remember that, it's, if I have x to the m over x to the n, that equals x to the m minus n. If I have two things with the same base being divided, I can subtract their exponents. So we come to this and we'll take each term at a time. So we're going to simplify one term at a time. Because right now, that's a single term separated by a plus or minus sign. There's another term separated by a plus or minus sign in your final term. Numbers with numbers, everybody. 4 divided by 4 is 1. Exactly. So those cancel. X to the 4th over x to the 4th, that's also 1. Anything divided by itself is 1. And y to the y over y, that cancels out, and that's 1. And what's 1 over 1? You better not have said nothing. We talked about that. There's no such thing as nothing in math. Right? It's not 0, it's 1. 1 over 1 is 1, so that's just 1. Okay, I want to also bring up another concept with you. We're good. Okay, minus. Brother, we're just thinking too hard. Okay, 8 divided by 4. Numbers with numbers. 8 divided by 4 is 2. X to the 6th over x to the 4th is going to be x to the 6 minus 4, which is x to the 2nd. Okay, and y to the 2nd over y to the, what number is right there? That's right, it's a 1. And we don't write it, but it's there, so that's a 1 right there. And so this is going to be y to the 2 minus 1, which makes y to the 1, which we just call y. And we come over here, numbers with numbers, right? 12 divided by 4 is 3. Okay, x to the 8th over x to the 4th is going to be x to the 8 minus 4, which is x to the 4th. And then I have y to the 6th over y to the, that's right, 1 right there. So that's going to be y to the 6 minus 1, which is y to the 5th. Okay, Brother Jameson, did I do it all right?
Looks good.
Okay, Brother Jameson said it's good. So there's your answer to that problem right here, and here's your process. All right, let's go ahead and pause. Hiya! What's up? Hey. The problem that we just erased off the board was number 24 in your homework. So if you do it, you get extra credit. That's the hardest problem in all the homework. We have 2 problems up here right now that we want you to do on your own. So when we tell you, let's have you pause. Here are your steps. If you pause, you can see the steps, and then you can do these problems. You got a mono divided by a mono. Here you got a trie divided by a mono, written in those different formats. Follow these steps. So go ahead and pause.
All right, so let's take a look at the first one. Number 4, 16x to the 7th divided by negative 2x to the 2nd. The first step, well, place mono under each term in the poly. Already done. So the second step, we're going to go ahead and simplify one term at a time. Numbers with numbers. 16 divided by negative 2. Well, positive divided by a negative, that is a negative. 16 divided by 2, that is 8. So you have negative 8. There, we're done with our numbers. With numbers. Then we say x's with x's. X's with x's. So, x to the 7th divided by x to the 2nd. This is the same as saying x to the 7 minus 2. Remember, going back to the quotient rule, which is, they're right, x to the 5th. So,
say woo if you got it right. Woo!
All right, and there we have the answer to the problem. Let's go ahead and take a look at this next problem. Here we have a trie divided by a monomial. We can go ahead and do that first step, place it under each term in the poly, so I say 24x to the 6th plus, and I divide that by negative 8x to the 2nd plus 32x to the 5th divided by negative 8x to the 2nd, and then I say minus 8x to the 2nd divided by negative 8x to the 2nd. All right. So let's first take a look at this one. We say numbers with numbers. 24 divided by negative 8, that is negative 3. X to the 6th divided by x to the 2nd, that's the same as saying x to the 6 minus 2, which is x to the 4th. So we're done with that first one. I'm going to go ahead and cross that out so it won't bother me. 32 divided by negative 8, well, that is negative 4. And then x to the 5 divided by x to the 2nd, that's the same as saying x to the 5 minus 2, which is x to the 3rd. I'm going to go ahead and cross that one out. Next step, negative 8x squared divided by negative 8x squared. So the negatives are going to cancel each other out, and we'll be left with a positive. 8 divided by 8, 1. X squared divided by x squared, 1. Any number divided by itself is 1. And so we are left with plus 1. And so we have negative 3x to the 4th minus 4x to the 3rd plus 1. Did you get it?
Woo!
Woohoo! Hope so.
All right, that's everything from section 4.8. Have a good one.